I was born in Guadalajara, and I always like to point out where Guadalajara is, because if you don't know, you should know. And you should know, if nothing, because of those plants right there that make what, Selene? Tequila, yes, so you should know that, right? And all good things come from Guadalajara, like Selene comes from Jalisco, like me comes from Jalisco, like, and tequila, and so, and mariachi, and like all the other good things in Mexico, they just come from Jalisco. So, great state to be born in. So that's my grandfather right there, and it's a very bad lighting for the picture. But I always liked school, but I never really liked math. I found that math was like, this mechanistic thing that you had to remember and like memorize and stuff. And I found it really, really hard, because I had a lot of things that I found hard when I was young. They told me I was never gonna be able to read like normal people, because I had like dyslexia. And then I was really bad at memorizing, so I couldn't like learn the multiplication table. So like, I was getting good grades, but it was just really hard. But I was really fortunate, because I was born to that family. My grandfather, you probably don't know because you're all too young, but is a famous soccer player, was a very famous soccer player. He played for the Mexican team, of course, for the Mexican team, and played in the World Cup. And because of him, all of us we didn't do sports, but not all of us did sports, but we understood that nothing is hard, you just need to practice, right? That is something that I was born just not knowing, that it's not that you have talent or not talent. You can have talent, but really all that it is you need to practice, right? So when I was a little kid and I couldn't know the table, that I couldn't remember the multiplication tables, I just practiced. And when I couldn't read, I decided, well, I just need to read a lot and I just need to practice. And that was just in my mind, not like, I'm never gonna be able to do this, I just need more practice, right? So I say this because I want you all to think about that our paths sometimes, like you see all the successes of people, I want you to see that some of it are successes, yes, but some of it are pure luck. If I had been born to any other family and they would have told me you can't read, you can't memorize, and you can't multiply, I might be a completely different person, right? But I was born on the right family that it was just like, okay, you just need to practice. And I was like, okay, that's normal, I just need to practice. So that was me. I discovered the Math Olympiads when I was in 6th grade. And many might not know what the Math Olympiads are, but the International Math Olympiads is starting this week, and I'm really excited. So I'm one of these geeks that like watches who's gonna get more medals and stuff. Back then, Mexico only had 3 silver medals, and I won the state championship in Jalisco, which, as we have established, is the best state. So it was one of the best states for the Olympiads as well. I won the first prize, a gold medal on the state competition when I was in 7th grade. And this is a competition for 11th graders. So, like, I didn't know any algebra, and all the thing was algebra, but if you don't tell somebody that they don't know something, they don't know that they don't know, and they just do things, right? So, I didn't know that I didn't know, and I had fun with the exam, and I did the exam. But I won it when I was in 7th grade, right? So everybody started talking about me, even people I didn't know, saying, this is gonna be our first gold medalist. And everybody like just said, oh yeah, she's gonna be a gold medalist, because look, she has 5 years in this Olympiad that she could just become a gold medalist. And not only did I never become a gold medalist, I never even made it to the IMO. And it wasn't for lack of trying. And I wanna tell you that because failures are hard sometimes. That was one of my biggest failures, right? Like, I thought that's what I'm supposed to be doing, getting a gold medal for Mexico. Like, I mean, it's not the US, you guys get 6 gold medals every time, and it's like, who cares? But that would have been a really big deal, right? And a woman, like, man, like, that would have been awesome. But I didn't even make it to the team. The team has 6 people, if you don't know, and I was 1 point out of 120, 7th place. To go to the IMO, to the last IMO that I could have gone, which was in Japan. So that failure made me not like math for a while. But I still was the only thing that I could do, so I was like, I might as well stick to it, right? So failure is part of success. And failing at something that you think is like the epitome of like your career doesn't mean anything. I'm a really happy person now, and I didn't need that success. And I learned more from that failure, so just a reminder. I went to college to Guanajuato. If you do not know, Guanajuato has an Institute of Math, just like this Institute of Math, but for Mexico, which is called CIMAT. And they have programs, so if you ever want to go study abroad, check it out. They have really good programs in which you can go. They're in English. They're super cheap because it's Mexico. And if you are in the Midwest or somewhere like me, where like there's never sun and it's like kind of icky weather, it's beautiful weather there. So, and here's some pictures in case you want to be convinced. That's where I did my undergrad, yes. In that giant thing in the corner right there, that's the Math Institute. So it's a pretty cool place. I did 3 years there. And then after the 3rd year, there was an opportunity to do an REU. So you don't know what an REU, this is the perfect place to ask people about that. So I came like one of those Mexicans that just come to the US, and I just stayed like some of those Mexicans that just come and stay. So. Anyways, so I put pictures of my undergrad and my education, and they're not pictures of me doing math, and that's on purpose. Like, do math, that's great. Math makes you happy, but do other things, right? I'm a terrible soccer player. Women in Mexico don't play soccer. Now they do, but back then, they didn't. So I am a really bad soccer player, but I didn't care. I had fun. We played, we lost, and we won, but that's okay. Anyways, I came to a summer program, did an RU, went to Texas. I also put there that I did not take it as seriously as I should have. Because one sometimes might think that if you have an opportunity, take it seriously and do it well. But if for some reason that doesn't work out, that's, again, not the end of the world, right? Like, things happen. I learned that I like math biology, but I do not like neuroscience. And that's funny, because the talk that I'm going to give has neuroscience in it. But but back then I thought, I just don't like that, right? So, go to conferences. That's me at conferences. I met my advisor there. I didn't want to do a PhD. I wanted to go back home because everybody in my family was like, okay, so when are you going to get married and the kids? And like, what are you doing this math thing for? Like, where's the money? Like, nobody understood, right? And some of you are nodding because you know what I'm talking about. There's your more like, mija, y los hijos? So, mija still doesn't have hijos, so my mom is still not very happy with me. But, and they really wanted me to go back home. But I met my future advisor there, and he was a great dude. We talked about soccer, and that's how he convinced me to go get a PhD. But it happens, right? So when you meet people here, you never know what opportunities are going to open up for you. So go meet people. And people here are super friendly. As Mariel, Dr. Vasquez, says, this is a very unusual conference, so take advantage of that. We are here because we want to be friendly. We're not here because we want to be mathematicians that are super serious and do only serious math. So approach us, and you never know what can come from that approach. All right, this is a little bit of the math that I did for my PhD, some medical implant stuff. I did models that look like that, so it looked like a computer. I put that there because there were 3 classes that I failed in as an undergrad. A bunch of times. One was computer science, and one was probability, and this is like full of probability and computer science. So failure just makes you an expert when you have to do it twice or 3 times or 4 times, and many times. Anyways, that's home now for me. I'm all the way there. Those are pictures, and I chose really pretty pictures. I like the snow. I'm obsessed with the snow. But some people don't. But it's really nice. And I wanted to put a list of all the stuff that I do so that you don't think that if you choose something right now, you're married to that thing. Like, math is not like a marriage. You can cheat, and you can cheat with as many people as you want. So there you go. I do a lot of different things. So those are some of the things that I do. And I'm going to talk about one of those, the first one right now. Also, questions, comments. I tend to talk fast. We good? All right, we good. So now we're going to do some math, and we're going to talk about some math, but because it's a math biology thing, first we're going to have to do some biology. So I'm really sorry, because I know some mathematicians are like, ugh, biology. But this is cool biology, I promise. Okay, so some general questions. And when I give this talk, people are like, yeah, but I mean, we all know what sleep is. And I will say, no, you don't. You all do it, but you don't know what it is. So we're going to talk about that. We're also going to talk about why we sleep and how sleep and thermoregulation relate to each other. And we're also going to talk about what thermoregulation is. So no worries here. There's no word to importance. And if you ever have questions, just raise your hand, because I will have questions for you. So, then we're going to do some math. We're going to say how we model sleep and how we incorporate that thermoregulation on the model. And a little bit of some analysis and results, even though this is old. Some people decided to have kids instead of, no, I'm sorry. I always say this, right? Like, we started with like 1 kid, and now the project has like 7 kids and only 2 papers, so that happens. Yeah, they're prolific with the kids. Okay, we also want to figure out what the role of temperature has on the structure of our sleep. All right, so what is sleep? we all do it. I mean, when I say we, I don't mean only people, like animals have sleep. Bacteria has something that could be considered sleep. Everywhere, across species, anything, animals, even some flowers, right, that you see that like they close their petals. Like there's some sort of sleep happening in a lot of different species. So, and if you think about not humans, but imagine a little rabbit in the middle of the forest, losing consciousness and not being able to move. That's terrible. Like you know, like what do you say? Like evolutionarily, biology. Yeah, evolutionarily, that's something very stupid to do. Like a fox can come and just eat you in the middle of your sleep, right? Like, so there has to be some really good payoff for this, or really good reason for this, so that we have evolved to do that. Does that make sense? Yeah. Okay. It's also non-uniform. REM is not only a really old band; it's also rapid eye movement. Right, so it's that stage in the sleep that we're having dreams. But if you have babies and you've seen your baby sleep, their eyes move really fast while they're sleeping. Have you ever seen that with the babies? Yeah, it's really cool. And then we have non-rapid eye movement sleep. So we have both things, and they look something like that. So everybody does it, and until recently, and by recently I mean the paper is 2016 paper. We really didn't know why. There was not a unifying theory of why we all across species sleep. Which is fascinating that it took us that long, right? All right, first question for the audience. These are stages of sleep. So we have being awake. Oh, okay, these are your brain activity. The brain activity while you're doing these things, right? So they put the sensors on the EEG, the sensors on your brain, and they measure the brain activity. So what do you notice? And you can answer. Patterns. There are different patterns. Patterns, yes. What else? Yes? The REM sleep kind of like the awake pattern. Bingo, and so fast. Yes, yes, right? Like there's something weird happening that REM and awake look pretty similar. What else? Same with K-complex and delta. Same with K-complex and delta. Very good. Theta is like in between the two. You see the planetary spikes? Yes. Yeah, yes. All right, so just as a little synopsis of what this is, awake is just, being awake. Calm wakefulness is like when you lie down but you're still awake and you're not really moving. Stage 1 is what me and only me, I've never heard anybody else, but I describe it like this. You got here on an airplane, any of you? You flew here? Have you ever taken a nap on an airplane and you can hear the baby crying and you can hear the little thing but you're still kind of asleep? You know what I'm talking about? That's stage 1. Okay. Stage 2 is a little bit deeper sleep than that, and stage 3 and 4 is that deep sleep that you have sometimes and that you just knock off. You know what I'm talking about? Okay. This is what a human sleep pattern looks like at night. We all have wearables now, right? And you sleep with it, you get a little thing in the morning that says oh, you spend that much time in REM. A lot of people after I give this talk tell me, oh, I don't get enough deep sleep. Now you're not supposed to, so chill. So we're supposed to have a little bit of deep sleep and a little bit of REM and a lot of light sleep, all right? So we're gonna talk about the percentages and stuff like that, but that, by the way, was a random night. I took away the timings because I thought people are just going to make fun of me. But this particular night, I fell asleep at about 7:35 Selene, and I woke up at around 3:40 something. So, and that is very normal. I'm a very well circadian, and trained adult. I go to sleep super early, and I wake up super early without an alarm. But if you notice, the thing that there is to notice is that you go from being awake to non-REM, right? And then you go back to REM, and then you go do this. And we want 4 or 5 of these things happening through the night. And we want the REM bouts to be elongating toward the night. The closer to waking up, the more REM that you get, the longer than your REM bouts are. And the closer that you are to being awake, the less deep sleep that you have. So when your mother told you the good hours to be asleep are early in the night, she was not just lying to you to get you into bed. She really meant it. It's actually true. You get the deep sleep at the beginning of the night. Questions, comments? All right, that is me. And you see the bouts? You see it goes REM, non-REM, REM, non-REM. Okay. Okay. So it's a big deal because, again, if you don't sleep, we know that there's all these really bad things that can happen if you don't sleep, right? Like, in the immediate term, if you are sleep deprived, there's can be, like, I mean, all of us have been sleep deprived. It is a very sad statement, but I bet that none of you can tell me, yeah, I've never been sleep deprived. We've all been sleep deprived, right? Except Cynthia. Cynthia has never been sleep deprived. No. We've all been sleep deprived, so you know that when you're sleep deprived, you just don't function the same, right? And you can notice that you don't function the same. You might also notice that you're colder during the day if you don't sleep, so check it out the next time. Please don't be sleep deprived on purpose, but if you happen to be sleep deprived, try to notice that. If you don't sleep for a long time, the funniest thing that happens is that the first thing that you lose is your ability to realize that you're sleep deprived, which is a bitch. Yeah, it's a really bad thing. That is a really bad thing. But evolutionarily, it makes sense because first I always thought it was because of war. Like, you know, we've been in wars or we've been in periods of drought or in periods in which we had to like migrate a lot when we were nomads, right? So we evolved so that we couldn't tell that we were really sleep deprived and we could continue. But then I learned that mothers, I don't know how you women do it, just don't sleep. And you need to not kill your baby, I guess. I guess that's a good thing. So you need to like be, like, not realize that you're incredibly tired so that you can continue doing this mother thing. So don't have kids. Okay. And if you already do, try to sleep as much as you can. Anyways, the other things that can happen when people are chronically sleep deprived is you can see depression, diabetes, autoimmune disorders, reproductive disease disorders, like things like that happen when you are chronically sleep deprived. So people that tell me, I only sleep 4 hours and I feel fine. Yes, you have lost your ability to realize that you're tired. But try it for a while. Sleep 8 hours, and don't tell me 1 or 2 days. Like, sleep for a while. You're 8 hours, and you'll see a huge difference, right? Right, ma'am? Okay, good. I told that to Cynthia, because she was the first one that said, no, I sleep 4 hours, and I'm fine. And I was like, no, you're just crazy. Okay, so this was the whole conversation. Yes, okay. So what are the disadvantages of being asleep? There's a bunch of disadvantages. You're vulnerable to predators. You do not spend that time acquiring resources. And if you're an animal, you know those resources are food and shelter and things like that. And if you're a human being, I mean, this money, right? It's time that you're not spending working, so it's time that you're not being productive. You're not taking care of your kids, and you're not taking care of reproduction if you're an animal or if you're a person, right? So those are things that are very bad. There's some advantages, but they have to be like super big advantages, and that's what the 2016 paper from Dr. Marcus Schmidt told us, which is the energy allocation theory. So, who here has a car? Do you take it to the shop to get service? And if you don't, like, then like sometimes it doesn't work very well, right? Okay. So this is what we do while we sleep. So we should think about when we're awake, we're just using our car, we're using our body, we're thinking, we're doing things that we do when we're awake. But when we're sleeping, we're doing all of those things that are like taking care of your car. So things that are taking care of your car are synthesizing proteins. So if you want to build muscle and you spend a lot of time at the gym and then you didn't sleep, well, let me tell you how bad that is for you. If you spend the entire night memorizing stuff for your exam the next day, you did not have the time while you were asleep to put your short-term memories into long-term memories. So, I mean, you just wasted a lot of stuff. So sleep actually helps you learn. You do other things like process emotions. You do other things like your nerve endings through the day when you're stressed, they like peel out the little fatty thing that goes around it. You need to sleep in order to have that little fatty thing put back in. So those are important things that you need to do while you're awake. Who wants to tell me what thermoregulation is? Yes, ma'am. Yes, you can tell me. Yes, it's regulating your temperature, right? Like some Californians cannot handle when it's lower than 60 degrees, right? So you have to try to keep yourself into comfortable temperature. While we're awake, there's a lot of things that we do to thermoregulate. We move, when we're cold, right, we shiver. What other things do you do when you're cold? You put the heat up, but if you don't have the heat inside your body, what other things do you do? Snuggle, good. Yes. Your muscle fibers, like they start like, getting like contracting. Also your veins. Your veins start contracting, so if you're really, really warm, you'll see your veins pop up because they're expanding so that they can be closer to the surface and they can cool your blood. If you're really, really cold, you can see them disappear because they're contracting so that there's friction when the blood comes in and that warms you up. We do very few of those things when we're asleep, and we do none of them when we're in REM. So that's what the big deal is. We do not have any thermoregulation while we're in REM. So why are these things? Anybody who has a guess of why we would not thermoregulate while we're in REM? Not Selene, because you wrote that paper with me, so that would be cheating. Yes. So thermoregulating is incredibly expensive. Now, I'm going to warn you, when I gave that talk to a room full of AWM women that were attending the talk, they said, oh, so if I want to lose weight, I can just put my heat really, really low? And the answer is yes, but it's also super unhealthy, so don't do it. But it is incredibly expensive. You spend a lot of energy trying to maintain your body temperature. So if you don't have to do that, there you go. You have all this free energy to do all these other wonderful things that you're supposed to do while you're sleeping. Does that make sense? But because you're not thermoregulating, you cannot spend a long time on it, or else, you'll die. Your temperature would deviate to the temperature of the room, which might not be ideal. So the motivation is trying to figure out how, if we sleep at different temperatures that might not be ideal, how does that mess up with our sleep patterns? And it makes sense that it will mess up with our sleep patterns because we won't be able to stay a long period of time on REM because we'll be deviating to bad temperatures. Does that make sense? All right. Okay. So first, when you do math biology, you look at data and you look at experiments. And then you get really, really mad because you realize that all the experiments were done in men between, 25 and 30 years old that were completely fit and had no disease at all because, yeah. So now we're going to pretend that we all are like that. We are all just men that are between 25 and 30 and are incredibly fit. And that because that's the data that we have, right? So that is my pitch for if you ever do biological or medical research, please diversify your subjects. It's important. Anyways. So here are the experiments that were done. Those temperatures are in Celsius because everything should be in the metric system. But just in case you don't know, what is it, 29 is about, it's 80 something degrees, I don't remember. I never paid attention because it makes sense to me in Celsius, but yeah, okay. So you might say, this is thermoneutrality, 29 degrees Celsius, and it's really, really warm, but by that I mean it's the temperature above your skin. So if your room is at 66 degrees and you have a light blanket, you achieve 29 degrees Celsius inside, on top of your skin. Does that make sense? And very few of us live completely naked in the middle of the room like this with nothing. So that would be the people that would have to have it at 29 degrees on a hammock, so there's nothing that you're touching. Yeah. So most of us live with a cover, so you need a cover, so you need the room to be a little bit colder. The numbers that I'm showing there is, they made people sleep at different temperatures. 21 degrees is much colder than 29, and 37 degrees is much warmer. And they did make these subjects sleep with only very few clothes, in no blankets, and in a room that was exactly that temperature. And then they measure how well they slept. They measure how much time they spent in each stage, how much REM, and how much total sleep. So you can check how you sleep really well here, right? If you look at the wakefulness, that means that the wakefulness and the sleep latency are the same, meaning that it took you, that the only time that you were awake was while you were falling asleep. You did not wake up through the middle of the night, right? So that's a good thing. You don't want to wake up through the middle of the night. But if you look at the other ones, when it's really, really cold, you wake up a lot, right? And when it's really, really warm, you wake up a lot too, so that's not good. Okay, so now that we have the data, we want a model that mimics that data or that mimics human sleep. We use a model that somebody else had done because that's what mathematicians do, and they don't tell you sometimes. They say, oh, that's my model. Yeah, but you based it on somebody else. So yes, we based it on somebody else's model, but we made it better, and that's good enough for you, for anybody, right? You grab something and you make it better. So our model looks something like that, and if that doesn't make sense, it's because I haven't explained it. So here's what this is. Circadian process, anybody knows what that is? Oh, and then I put it there, so you could just read. The circadian process is like your pacemaker. So we all have this 24 hours clock inside. You all heard about that? Like, and if you're somebody like me that goes to bed at the same time and eats at the same time and does everything at the same time, or you have a dog, because I'm like a dog. If you have a dog, you know that they sleep at the same time, go to the restroom at the same time, do everything at the same time. They have a really good circadian rhythm, right? So we all have that. That's the one that it doesn't matter that I'm in California, I'm still waking up at 1 in the morning because my biological clock is like, it's 4 a.m. It's 4 a.m., you get up. And I'm like, dude, I went to bed super late. But it doesn't care. Now, that looks like this. And everybody in the audience knows that that's kind of like a sine wave. So it makes sense that the function is a bunch of sines, right? This period right here, this is measuring your temperature. So all of our temperatures varies 1 degree up, half a degree up and half a degree down during the day. And the ideal time to go to sleep, if you ever want to know for yourself, is when your temperature is dropping the fastest. And people with kids will know that you bathe them at night, so that when you take them out of the bath, that is like the fast dropping temperature, and they're like, right? So that's why, if you cannot sleep, those are good things that you can do to trick yourself into falling asleep. The homeostatic process, that's the one that is fighting my urge to go to sleep later. That is the one that tells you, you've been awake for a long time, so you need to go to sleep. Right? It's a push that the longer you stay awake, the more that it wants to go to sleep. That just looks like this Heaviside function, which means it grows through the day, but of course, when you're sleeping, it has to decrease because you're sleeping, so your need to sleep should not be increasing, and then it does the same the next day. Everything makes sense so far? Cool. All right, those are just neuronal components or parts of the brain or areas of the brain or like neuronal clusters. So the brain looks like this, and you don't need to know where they are, but these are their names. If you do know some biology, now you can know what we're talking about. And those kind of neurological diagrams, what it means is if this area of the brain is firing, if your neurons in that area of the brain are firing, they excite that area of the brain so that it fires as well, because it's an arrow. When you have a little thing that ends in a ball, means that when this area of the brain is firing, it makes that area not fire. It inhibits the activity in that area, right? So when we have an arrow, it makes it excited, that area. If we have a little thing with a ball, it inhibits the activity there, okay? So that means that, and we model these interactions between those areas with Morris-Lacquer equations. If you know any neuroscience, mathematical neuroscience, you know that these model the activity of one neuron. So we're pretending the whole collective is one neuron because sometimes we have to do simplifications to make our models like work, right? All right, so this is one neuron, but we're pretending there is a bunch of them. Okay, these are the areas of the brain. They interact like this. These are just differential equations. We're not gonna spend too much time. And we don't spend too much time solving them. We spend a lot of time analyzing them and then a lot of time having the computer solve them because what are computers for? So this is what you need to know. When we're asleep, these are the areas that are active. And again, because they're active, they're inhibiting these areas, so that's why they're off. And when we're awake, these are the areas that are active, and this one is active too. These ones flip-flop between being active and non-active because I told you that you can be either in REM or non-REM. Okay, we ran our model. And by the way, the model that we based it on did not look like this when we ran it. So we made it better, and now it looks like this, and it's pretty. Look at this. You fall asleep, you have 5 REM bouts, which is what I told you we wanted, right? I told you we wanted them to elongate through the night, so they do that. And it's like about an 8-hour nighttime. So it's beautiful. It's exactly what we wanted to do, and it's doing it really well. And we're making it do it at thermoneutrality. So everything's great, and then what do you do? Because it would be really illegal for me to grab one of you and like severe your brain or like make you do all this. We do it in the computer. In the computer, we can severe their brain. We can do all sorts of experiments, and that's why we do applied math, right? Okay, so now everything looks really good. Like I told you, we were doing exactly what we wanted the model to do. Now we want to add the temperature effects and see what happens. Actually, a bunch of these areas of the brain sense temperatures, but we chose the ones that have the most temperature sensing capabilities. So the POH and the REM off are the places we're going to put the temperature effects. And this is a model of the temperature in a fish. So we're considering human beings like a fish. But like fish, when they are swimming around, if they want to be warmer, they go up on the river or on the ocean. They want to be colder, then they go down, because they don't have capabilities of like thermoregulating themselves. But we do, so this is what we're doing to pretend that we're kind of like fishes. So now that we have that, we have the different parts of our temperature effects. Pretty much these are heavyset functions that if we are too cold, they make us warm. If we are too warm, they make us cold. If we are too cold, they don't do anything to make us colder. So that part of the equation is like a 0. And these are just like Michaelis-Menten equations. You don't need to know, but they look like equations that you've seen before, so they're not super scary, I hope. Now, this is what happens when we plot this. This would be you without being able to thermoregulate. So at REM, right? At REM, you are not able to thermoregulate. So if the temperature deviates from that 29 degrees, you just go up or you just go down. Now, if you are awake, you can thermoregulate among all of these temperatures. So in between, like, what is that? Like ambient temperature of like 10 degrees and ambient temperature of like 40 degrees Celsius, you don't die. Pretty much. Past 40 degrees, this is why some Mexicans moved to Ohio, you have trouble thermoregulating, and before that you have trouble thermoregulating, but you could still wear more clothes, which is my point always. Like, you just put more things on. Okay. So what we do is these are the things that we do with the current model, and these are things to be improved, right? Like right now what we have is we are running this for 37 degrees. So the night, if you notice that it's a little bit shorter, we only have 4 bouts, and they're very small in comparison to the good night. Remember the good night, they were like really big. So we have shorter REM bouts. And this is what's happening. Your temperature starts like deviating from thermoneutrality, and then you go to the danger zone, and then you wake up, which is unrealistic because normally you wouldn't wake up necessarily. You might just go into non-REM and move a little bit, or you have other ways of saying it, but for the first try of the model, this is good enough. We make you wake up and you go back to non-REM. You spend some time in non-REM, and then you go back to REM. Make sense? All right, so now that we did that, we tried to create some experiments, just like the experiments that we had, and see how good our model is at creating those experiments, right? At replicating those experiments. So we have some REM lengths there. We do kind of do what the experiments were doing. We have some significant reduction of REM if we go away from thermoneutrality. We have a lot of wakefulness if we are not sleeping at the right temperature, and we don't have the right amount of REM of cycles if we move away from thermoneutrality. So that's what we wanted our model to do, and that's what it does. So then we started trying to figure out, what do other studies do, right? What do other studies that people do in sleep, how do they do these studies? Because something that would be really interesting is, who here is from the East Coast and is having a terrible time at night, right? Like people want you to still be awake. Some people want you to still be awake and you just want to go to sleep, right? It's terrible. Yeah, me too. I woke up at 1, and she doesn't believe me, and I've been here for like 4. Yeah, no, it's terrible. So something that would be really, really interesting is trying to figure out how to deal with this jet lag, right? What would help you adapt the fastest? And now that we have a model, we can figure all of these things out, right? But then we figured out how they were. First, we had this paper that did this experiments with the night. So we thought they made somebody sleep at 24 degrees, then 29, then 21, then 34, then 37, and then, and then 34 degrees, and then see what happened to their lengths. So we want to know what temperature or like a bad night of sleep does to sleep history. And so we plotted a bunch of things, different things of like what is doing to you, the night length, what is doing to the number of awakenings. This is at ambient temperature, so you should not have any awakenings. These are just like different mean REM durations. When we make you sleep the 3rd day at those different temperatures. So this is what we did. And now we started you at a different temperature for the 1st day, and then the 3rd day do a different temperature and see what happens. And then we discovered that the person that did these experiments actually had them go back home, adapt to what they were doing normally, and then come back. So the next day was actually 3 days later. So then that's why our data wasn't matching. So a good moral of the story. And I'm telling you the good and the bad, right? Like I'm telling you this is a really good model, because it is a really good model and it got published and it's great. But you then find out that sometimes the data that you have is like really bad data. And sometimes you gotta, sometimes people publish things and they don't tell you the whole story. So like, it's okay to find struggles like that, because I mean, that's what we do, right? Like somebody doesn't show up and then you get the best crazy person to just go give a talk. Okay, yeah. So sometimes these things happen. Anyways, summary of what we did, we took this sleep-wake model and we incorporated that ambient temperature, right? That's what we started with this sleep-wake model that was normal, then we added the temperature, and then we put input body temperature as a component. Now, as I was telling you, this temperature effect is like we're a little dot, like we're a little fish and we go up and down. That is very unrealistic, and there's a lot of biology behind, like there's a lot of knowledge in biology about how REM has a cooling effect on the rest of your body. So when your brain is doing all of these things, it's obviously getting warm, right? So if your temperature is a little bit, the temperature in the room is a little bit lower, that's actually really good, because then that would cool down your brain, right? There's a lot of different things that have been noticed and experimented with about the temperature in your feet and the temperature in your hands when you go to sleep, and how it should be different than the temperature in your. So we should model this as a whole person, or at least a cylinder with like extremities. But right now it's a point, right? So that would be something really cool to do in the future, and that's something that people are doing. If you ever like find, there's all of these things that are being developed to improve your sleep, right? Like there's like thermostats that like would cool you down through the night, emulating when we were nomads and the temperature would normally, drop in the middle of the night. There's these mattresses that warm up your feet, right? And all of these things come from studying these things. So if you care about more than academics and more than knowledge and just money, like this is good things to do, and do experiments that you can sell, to like mattress companies and things like that. People always want to sleep better because nobody wants to not work that much so that you can actually sleep better. But anyways, we have our system also like produces awakenings, and as I was telling you, those are not great awakenings yet. We could have a model that takes you to non-REM after REM and then wakes you up after that if you were not able to thermoregulate enough. That's for the future. Then we do have really cool stuff, like it is very consistent, and it mimics at least in the thermoneutrality a lot of the good things and in the variations. But we need more stuff that we could do to this, right? We could have the dynamics of awakenings to go to the non-REM, as I was saying. We could add a lot of stochasticity to this, because it is true that my ideal temperature is not your ideal temperature, right? I'm saying 29 is thermoneutrality, but it really for who, right? Like, so we all have different temperatures at which we sleep. And it also has to do with the distribution of your body fat and with all these other things. So there's a lot more to study there. Biologically, I would love to do things with shift workers, because between when I was an undergrad and I came to the U.S. to do my PhD, I had to go to Mexico because they don't like us to be here after 30 days after you're done with your degree. You need to get out of the country. So I went back to Mexico, and I couldn't get a job, anything with my degree, in anything for the summer. And I need to save to come back. So I work at Starbucks in Mexico. And in Starbucks, because you're the new kid, they give you the closing shift one day and then the opening the next, like a bunch of times. So since then, I've been very curious about how that like messed up with my sleep and how like all these things could happen. We also want to understand the interactions between sleep history and the properties of sleep. Like, if we already know that when you have a really bad night of sleep, you are worse at thermoregulating through the day, how does that affect the next night that you go to sleep, right? And then we can do all these other things, like with the theory that is being developed of why we sleep, and it's being still developed of like how all the other animals and other species sleep. How do we add this to our model? Something that is really, really cool is that this work was done by only women, and that's not that common, but it's pretty great. And you might recognize some of these women right there. And she was actually carrying another amazing woman who was your daughter because you were pregnant there. And then these are the 6 of us, and Dr. Marcus Schmidt, who's a biologist that wrote this paper, and we don't have him in any picture because I guess we don't like him. But no, he was really, really nice. But I don't know, it's really impressive to see that, there's 6 women doing research. And this work was funded by the NSF, and it's been published into different publications, so you can look for it with all the stuff. And thank you, and I'm done. Anybody has questions?